Hello guys, welcome back to the AGROS channel. Today we will be learning the agrometeorology. This is the third part of agrometeorology. So please watch the previous two videos for better understanding. In this video, we will be learning about spheres of atmosphere. Okay. First, we will be learning about the names of the atmosphere, spheres of the atmospheres. The first layer is the troposphere, then comes the stratospheres, then comes the mesospheres, then comes the thermospheres, and lastly the exosphere. One thing to notice that I have shown over here 5 layers, okay, 5 spheres of atmosphere, but in majority of the books it shows only up to 4 spheres only. Okay, up to thermosphere it is only mentioned because exosphere is the last sphere, and why it is not included in most of the books we will see it in the later part of the video. So continue to watch the video. This image clearly shows the layers of the atmosphere and some users of the layers. Okay, firstly, we can see that troposphere is the first layer. It is the closest layer to the Earth's surface. It starts from the mean sea level up to 14 km above the mean sea level. Okay, 14 km above mean sea level. This is an average height. It is not the exact height for all over the surrounding the Earth's surface. Okay. Like it changes near the equator and also changes near the poles. We will study in the further when we discuss troposphere deeply. Okay, the next layer comes the stratosphere. In the stratosphere layer, there are few hydrometeorological phenomena takes place, and then comes the mesosphere layer, where none of the agrometeorological phenomena occurs, but a few we can see few clouds. Okay. There are special clouds called the noctilucent clouds. Okay, these are special clouds. And then comes the thermosphere. This is one of the largest sphere. Okay, this is the largest sphere. And the last sphere, which includes the exosphere, in which the satellites, you can see the satellite images given there. In the exosphere, only the satellites are roaming around the Earth. Okay, then the thermosphere. It is the all jets, the rockets, powered jets can reach this layer. Okay, the sounding rocket image is given. Then the southern lights and the northern lights, which you can see occurs in this layer, the thermosphere. This image is very good. Okay, it can generalize the users of the layers and why it is important to us. Okay, and one more thing to notice is that the temperature variation in the layers of the atmosphere. We can see in troposphere, as we go up, the temperature decreases. But in stratosphere, as we go up, the temperature decreases. And again in mesosphere, the temperature starts decreasing. And in thermosphere, the temperature again start wet. I'm wrong, marking the arrows wrong. In troposphere, we said as we go up, the temperature starts decreasing, and in stratosphere, as we go up, the temperature starts increasing. In mesosphere, as we go up, the temperature starts decreasing, and thermosphere, as we go up, and in thermosphere, as we go up, the temperature starts increasing. Okay, and exosphere, it's always increases. In the exosphere, we can say that is we have reached all the outer space, so we can say the temperature decreases. Okay. Next, let's see the spheres in details. Okay. In the troposphere, first layer is the troposphere. Troposphere means tropo means turbulence and sphere means region. Okay. Turbulence, tropo means turbulence. Turbulence, why turbulence? Turbulence because all the agrometeorological phenomena occurs in this layer. The main thing is the height of the layer. Okay, 14, as I said, it is the 14 km above mean sea level on an average, but near the equator. Temperature is 16 kilometer above mean sea level, and at the poles it is 7 to 8 kilometer above mean sea level. Why this happens? Because we can say that due to the rotation, the Earth bulges near the equator. So we can see that atmosphere also bulges this portion, and due to the bulging of this equator, and we can say this at this part, it becomes a narrow strip. We can say it gets flattened. So we can say that the distance of the height of the thermosphere troposphere decreases at this part. Next, as I said, it is a sheet of the all the weather phenomena. Next, as I said, that it is a seat of all the weather phenomena, all the agrometeorological phenomena like the formation of clouds, lightning, thunder, rain, everything occurs in this troposphere layer. Okay, and one more important thing is that the temperature decreases as we go up, and the rate of decrease in temperature is known as the lapse rate, and the mean lapse rate is 6.5 degrees centigrade per kilometer. Okay, this is an important number. Just remember as it is, because it is asked in many of the examinations. Next is one more thing to notice is that the wind velocity as we go up increases. Okay, as we go up, the wind velocity increases. This layer, the tropospheric layer, is heated from below. Why? Because as this is the Earth's surface, this is the sun, and this is the atmospheric layer. As we know, the long waves, the short waves enter without any hindrance, but while returning back due to the presence of the carbon dioxide in the tropospheric layers or greenhouse gases present in the tropospheric layers, the short waves are not able to escape, due to which the Earth's surface becomes hot, and as the Earth's surface becomes hot, the troposphere, which is close to the Earth's surface, also starts heating up. Okay, so we can say the tropospheric layer starts warming up from the below. Okay, this layer contains 75% of the gases, total gases, moisture and dust particles, 75% of everything. Okay, the gases, moisture, dust particles, everything is present in this layer. Next comes this one more important thing to mention is the troposphere contains a silent layer where almost no agrometeorological phenomenon occurs. This is a transient area from our troposphere to stratosphere. Okay, means this is the troposphere. Means suppose this is the troposphere. This is a layer of, this is the stratosphere, and this is the tropopause. This is the transient layer or the silent layer which moves from troposphere to stratosphere. That is the middle of both the layers. Okay, and this troposphere also contains a small amount of ozone. This is also known as the bad ozone because it is not at all beneficial to us. Okay, it does not protect us from the UV lights like the ozone layer, ozone gases which present in the stratosphere protects us from the UV rays. So it is known as a good ozone. But the troposphere present in this does not cause any good, does not help us anything, but rather it is harmful for the plants and different organisms, because ozone is not good for inhaling. Okay, as you know, those of read chemistry knows this, that ozone is not good for human health, for respiration and different things. Okay, so and ozone was discovered by Charles Fevre and Henry Busson. Okay, this is the important thing, and it is ozone day is celebrated in September 16 every year, because we know that ozone is depleting day by day due to depletion of ozone layer. The ozone hole has formed. Okay, and now all the countries all over the world has signed the Montreal Protocol. Remember, Montreal Protocol. Wait, I mentioned this. Yes, over here, Montreal Protocol in 1987. It was signed by all the countries around the world to reduce the ozone depleting substances. To reduce the production and consumption of ozone depleting substances. Okay, so remember this thing also. First is, remember three things about ozone. First, that it is present in troposphere as well as stratosphere, but in troposphere it is in low concentration, but in stratosphere it is in high concentration, and it is very good for the humans, so it is known as the good ozone. Okay, and in troposphere ozone is not good, so it is known as the bad ozone. Okay, this question is a very important question, comes in the question examinations very often. Then comes the Montreal. Second point is that it protects us from the UV rays. Okay, third point is this, that it was discovered by Charles Fevre and Henry Boson. In the year, it is mentioned over here. It is not mentioned. Okay, it is not important. The year is not mentioned, so leave it. And in the and the fourth thing is that to protect the ozone layer, Montreal Protocol was signed by all the countries of the world in the year 1987 to reduce the production and consumption of ozone depleting substances like CFCs. Okay, this is a very good example of ozone depleting substances. Okay. Next here comes the stratosphere. It starts from the tropopause. The tropopause was where it ends at 14 kilometers on an average. So we can say it is roughly around 12 kilometers above the Earth's surface it starts, and its highest place is the 50 to 55 kilometer. Okay, and it is an altitude of 50 to 55 kilometer, and there is a stratopause also there, which is the transient zone from stratosphere to mesosphere. Okay. The atmospheric pressure at the top of stratosphere, the atmospheric pressure at the top of the stratosphere is the 1 by 1000 of the pressure at the sea level. This is a very important thing. Okay, the pressure is decreasing continuously. It is 1 by 1000 of the pressure of the sea level. The next important thing that is contains ozone layer, as we have said, and it protects us from the UV layers. And one more thing, the temperature in the stratosphere increases with the increase in height. Okay, this is the height, and this is the temperature. It increases. Why increases? Because the ozone layer present in the stratosphere continuously absorbs the harmful rays like the UV rays, and it warms up the stratosphere. So we can say stratosphere is the hottest layer or the warmest layer of the atmosphere. Okay, warmest layer. Okay, next we will see the mesosphere, and I mentioned that nacreous clouds. Okay, for details of the nacreous clouds, you can visit this site. You will get a very good detailed article on nacreous clouds. Okay, next is the mesosphere. Next, mesosphere starts from the stratopause, that is 50 kilometer, roughly around 50 kilometer, and extends up to the 80 kilometer. Okay, 80 to 85 kilometer, and it is the third highest layer, as we know, and it is the coldest. Okay, it is the coldest layer. Why? Because in this layer, it is the coldest layer. Why? Because in this layer, the temperature decreases with the increase in height. Okay, this is the temperature, and this is the height, and the minimum temperature is minus 85 degrees centigrade. Remember this thing, minus 85 degrees centigrade. Then if you remember this, you can easily convert to its Fahrenheit or Kelvin temperature. Okay, just below the mesopause, it is so cold that the water vapor, that is scarce water vapor that is present, sublimes directly to the polar mesospheric noctilucent clouds. Okay, noctilucent clouds. Noctilucent clouds, I have given the link before in the slide. In the before slide, you can see in details what is noctilucent clouds, and there are some phenomena. Actually, there is no agrometeorological phenomena, not agrometeorological, no meteorological phenomena occurring in this layer. Okay, but some phenomena like lightning-induced discharges, known as the transient luminous events, can be seen in this layer occasionally due to the formation of thunder clouds. Okay, this is known as tropospheric thunder clouds. Okay, the mesosphere is the layer where the most meteors burn up in the atmospheric entrance. This is the very important point. Okay, remember this point. The mesosphere is the layer in which most of the meteors that falls on the space to on the earth burns up. Okay, next comes the thermosphere, and it starts from the 80 kilometer to 500 to 1000 kilometers. Okay, and it is because thermosphere is below the exosphere, so it is also known as the exobase. Okay, and there is a layer of ions present in the thermosphere ranging from 80 to 550 kilometers. This ions forms a layer like the ozone layer and is known as the ionosphere. Okay, this is a very important layer. We will learn the importance of this sphere in the later slides, in the later part of the video. The temperature of the thermosphere increases with the increase in height. Okay, and this heating up is not like the heating up of the stratosphere, which is due to the absorption of UV rays by the ozone. In this layer, it is heating up due to the low density of the molecules, extremely low density of its molecules. Okay, this layer is completely cloudless and free of water vapor. However, some arrives non-meteorological hydrometeorological phenomena like the aurora borealis and aurora australis are occasionally seen in the atmosphere. Aurora borealis and aurora australis, also known as northern and the southern lights. We will see the details in the later part of the video. The International Space Station, very important thing, the International Space Station is located in this thermosphere layer. Okay, this layer, this height is the International Space Station is the of 350 to 420 kilometer above the mean sea level. Next, we will see the last part of the atmosphere, that is exosphere. Exosphere is the layer which mixes with the outer space. Okay, it starts from around 700 kilometer above the Earth's surface and extends up to 1000 kilometer, where it merges with the solar wind. Okay, in this layer, the atoms and molecules are so far apart that they can travel hundreds of kilometers without colliding with one another. Okay, so it stops behaving as gases and the particles starts escaping into the space, and these free moving particles follow the ballistic trajectories. Okay, what is ballistic trajectories? We will see over here. Okay, ballistic trajectory is a parabola with homogeneous acceleration. There is a homogeneous acceleration. Okay, continuous acceleration is there, such as in the spaceship, with constant acceleration in absence of other forces. There is no other forces acting on this, on the particles. Okay, ballistic trajectory. What is ballistic trajectory? So, what is a ballistic trajectory? It is a parabola with homogeneous acceleration, such as in spaceships, with constant acceleration in absence of other forces. Okay. Another term we saw is magnetosphere. Magnetosphere is the magnetic field of a planetary body. Okay, like the Earth has a geomagnetic. We know that the Earth geomagnetic, the range up to where the geomagnetism of the Earth occurs is known as the magnetosphere of the Earth. Okay, and solar wind. You know, solar winds are the solar particles that is released by the sun. They are highly energized and charged particles, and their speed is around 900 kilometers per second. This is not important, but it is only for general knowledge. Okay, general understanding. So the exosphere contains most of the satellites orbiting Earth. Okay, this is a very important point. The exosphere contains most of the satellites orbiting the Earth. Next, we will see the ionosphere, which I told about in the thermosphere. The ionosphere is a layer present in the thermosphere, which helps in us communication. How it helps us communication? The thermosphere has got ions. Okay, positive charged and negative charged ions. This is present in the ionosphere. So, when a transmitter sends a radio wave, the ions reflects the radio waves back to the Earth's surface, and there is a receiver over here, or it is reflected by the Earth's surface again to the Earth's in the atmosphere, and then like this it is reflecting and up and down, and finally there is a receiver. It is just the receiver, and the receiver translates the radio wave again to the analog or my digital signal. The aurora, which is mentioned in the thermosphere layer, aurora is of two types. First is aurora borealis and aurora australis. Aurora borealis is the northern lights, and aurora australis is the southern lights. How will you remember which one is southern lights and which is northern lights? Remember Australia. Australia is in the south. So aurora australis is my southern lights, and aurora borealis is my northern lights. Okay, northern. And how does this occurs? This occurs due to the mainly of the as we saw this how this occurs. This occurs due to the charged particles colliding with the solar wind particles. Okay, this due to the collision of the charged particles, we can see different lights in the sky or the atmosphere. Lastly, the International Space Station. It is a habitable artificial satellite present in the low Earth orbit. Low Earth orbit means we cannot say the lower Earth orbit. We can say it is present in the thermosphere. Thermosphere, okay. Thermosphere. We can say it is present in the thermosphere. It is a International Space Station is a joint project developed by different research space stations like the NASA of United States, Roscosmos of Russia, JAXA of Japan, ESA of Europe, and CSA of Canada. Okay, Europe Space Agency is Europe, and Canada Space Agency of Canada. This ICU atmosphere or the International Standard Atmosphere. The surface pressure of atmosphere is 1013.2 hecto. It's not hecto, sorry. It's hectopascal. It's hectopascal. Okay. Let me write it properly. It's 1013.2 hectopascal or millibar. Surface temperature is 15 degrees centigrade and air density at the surface is 1225 gram per meter cube. 1225 gram per meter cube. This is that is all for today. Thank you. Don't forget to like and subscribe if you like this video.